All right, so recap. We talked about finding the dimensions of matrices. We talked about each of the numbers in a matrix are called an element and how to locate them. We also talked about how to organize data into a matrix. Next, what we're going to do is we are going to learn how to add and subtract matrices. Okay, so here we are given a matrix A, B, and C. Let's add in D, matrix D. We're going to have it be a 2 by 2 matrix. So here we added in a fourth matrix. Sometimes when you are given a matrix, it'll actually write out a matrix A plus a matrix B. Sometimes it will give you a list of matrices, and then the problems will look like A plus B, and we'll have to write it out. So we're going to write this problem out with matrices. So matrix A is -1, -8, 3, 5, 4, -2. That's A. Plus matrix B is -5, 3, -4, 6, -2, 3. So that's matrix A plus matrix B. Sometimes it'll give you the problem how it's written here. Sometimes it'll actually write out what we just wrote and expect you to do the problem then. So sometimes you have an extra step to actually write out the problem. All right, so when you are adding or subtracting matrices, to add or subtract two matrices with the same dimensions, add or subtract their corresponding elements, meaning elements that are in the same spot. Okay? So -1 and -5 are in the exact same spot. So all I'm going to do is -1 plus -5 for my answer here. I'm going to write that answer in the same location. So what is -1 plus -5? It's -6. And even though you cannot type the matrices in on your basic scientific calculators, you could type in -1 plus -5. So as long as you know the rules, you can still use a calculator. Okay? -1 plus -5 is -6. Next, I'll do the top middle. With the top middle, and I have -8 plus 3. -5. Next, I'll have 3 plus -4. -1. Try the last three elements on your own. Were we able to come up with those last three elements?
Oh, absolutely.
Give me a 1 through 5. I think I can add matrices on my own.
I really like this too. This is going to be really great.
Good. Good. I'm glad you're liking it. All right, so next we're going to do B minus A. So this time, when we go to write these out, we're going to write B first. So our B matrix is -5, 3, -4, 6, -2, 3. We're going to have a subtraction sign in the middle this time. And then A, which is -1, -8, 3, 5, 4, -2. I will tell you the most common errors I see during this section and the next section is people record these wrong. Okay, when you're copying them down, double check that you copied it accurately because you want to make sure you're doing the correct problem. Okay, B was copied down correctly, so we're good to go. Now the same idea here as what we were doing before. So this one, you're just subtracting now in the same location. But make sure you're subtracting each of these. So we have -5 minus -1. What is -5 minus -1? not negative 6. It's going to be negative 5 plus 1, because when you subtract a negative, it turns into addition. So negative 5 minus negative 1 is negative 5 plus 1, which is negative 4. The next one is 3 minus negative 8. It's going to turn into 3 plus 8, which is positive 11. Negative 4 minus 3, negative 7. Okay. Try the last 3 elements on your own. All right, let's take a look. How did you do? Give me a 1 through 5. I can subtract. I got all 3 of those on my own. I'm feeling pretty good about this. Okay, let me give you another option of how sometimes people go about doing this. Okay? Some people don't like to subtract because they'll subtract like the first one and then they forget and they do 3 and negative 8 makes negative 5 and negative 4 and 3 make negative 1 and they accidentally just added them. So sometimes when people subtract, what they'll choose to do is they choose to change this to adding, and they'll go through and they'll change all of these signs on the inside. So you distribute the negative sign to the inside. So this becomes a positive, positive, negative, 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 positive. So that way they can just add it. Because 5 minus 6 is the same thing as 5 plus negative 6. So if you distribute the negative to all these terms in here, you can then just add. Well, negative 5 and 1 is negative 4. 3 and 8 is 11. So some people choose to go about subtracting that way. If it was easier for you with the way we just did it the first time, then keep it like that. If you want to just add every time, then you can just distribute the negative sign if you see that subtraction. Okay, you get to choose though. Okay. Now here is why I had to add in D. I want to show you what happens. We're going to do part C right up here because it's actually not going to take up a lot of room. And let's add A plus D together. And I'm not even going to write this out because what are the dimensions? Who can tell me what the dimensions are of matrix A? That is a 2 by 3 matrix. Plus, what are the dimensions of matrix D? A 2 by 2 matrix. When we draw out the 2 by 3 and a 2 by 2, is each element going to have a corresponding element? Like how we had here. These two are in the same spot, these are in the same spot, these are in the same spot. Is that going to work if we don't have the same dimensions? No. So if we have something like this, what we have to say is that this is not possible. Or you can tell me it's undefined, either one. So it's not possible because you can only add matrices with same dimensions. So whenever you tell me something's not possible, you have to explain a reason. Okay? So if I write not possible, I'm going to show that the dimensions are a 2 by 3 plus a 2 by 2 and state because you can only add matrices with the same dimensions. I've showed that they have different dimensions. Does that make sense? So that's what we're going to have to do on some of our homework problems. If they're not the same dimensions, I'm going to have to write not possible and explain why. By explaining, state what the dimensions are and state that they are not the same. In order to add or subtract, you have to have the same dimensions. Okay? Multiplying by a scalar. Now this works the same way as if there was a negative out front. 3 times C says that we have 3 in front of matrix C, which is 1, 3, 2, 6, 5, 3. That's our problem here. And it says multiplying by a scalar, which is just a number out front, a constant, a number. To multiply a matrix by a scalar, k, 3 in this case, multiply each element by that same number, in this case 3. So it's kind of like distributing. Each of these elements is going to be multiplied by 3. So the dimensions are still going to be a 2 by 3. We haven't changed anything there. This first one, what is 3 times 1? 3. 3 times 3 is 9. 3 times 2 is 6. Try the bottom row on your own. How did we do? Give me a 1 through 5. I can multiply by a scalar. All right, try the next one then. The next one is a negative number, so negative 2b. So negative 2 is out front this time. Matrix B is negative 5, 3, negative 4, 6, negative 2, 3. And let's figure out what this one's going to be. How'd we do? Give me a 1 through 5. I can multiply a scalar. I did everything I had to do on my own correctly. Down to a 1. I don't know what class this is. All right. So, the next one is going to be multiple steps. Okay? So if I have 3 times C minus 2 times B, I want you to think about if I were to have you do 3 times the number 6 minus 2 times the number 7. And if I were to have you do this operation using PEMDAS, what would I do first? Okay, the parentheses. Inside them is already alone, so parentheses are done. Then what? The multiplication. Okay, so what is 3 times 6? Okay, so this first number is going to become 18. What about this over here? Minus 2 times 7 is 14. And then what would you do? Then you're going to actually do the subtraction. So 18 minus 14 is going to be 4. Right. I showed you this with basic numbers because that's the same order of operation that you have to use when we're doing this with matrices. So what I mean by that is we're going to take 3 and multiply by C first, and we're going to take 2 and multiply by B first, and then what we'll do is we will subtract them. Okay? Or you could write this like this. 3C plus negative 2B. The same way here, you can write 18 plus negative 14. And those are the exact same problems. You're not changing it at all. Are we okay with that? Or you could have changed it up here and said 3 times 6 plus negative 2 times 7. Okay, so we just did that. Now, I broke it up this way because we actually already found the answer to what 3C is. We already did 3C in this problem up here. So we got this answer here. We already found what negative 2B was. That was this problem. So here's the answer to that portion. Do you see that? So we've already done the first step. If you want to do it again, you're more than welcome to. You are more than welcome to write out 3, the matrix C, plus negative 2, the matrix B, distribute the scalar to each element, and then add them. Or we already have 3C, which which we found that answer to be 3, 9, 6, 18, 15, 9, plus the negative 2b was this portion here, which we found to be 10, negative 6, 8, negative 12, 4, negative 6. And now we've already done one of the steps, so now all we have to do is add these matrices together. And when we add them, (3 plus 10 is 13. 9 plus negative 6 is 3. 6 plus 8 is 14. 18 plus negative 12, 6. 15 plus 4, 19. 9 plus negative 6 is 3. That's a smudge on there, not a negative sign, just so we know. There we go. Where those smudges came from. Give me a 1 through 5. I feel like I could do this multi-step one. Where are we at there? Or do you want to see another one? What's that? You good? Okay, so then that means that we've already checked in assignment 1. We're going to move on to assignment number 2. It says, perform the indicated operations. If the matrix does not exist, write not possible. Okay, if it's not possible, you must have an explanation. Okay? And I'm telling you that now because that is a requirement on your quiz, which it does state so in your quiz, so I want to make sure that we have the practice. Okay, so you must have an explanation. So number 1, you're adding. 2, you're adding. 3 and 4, you're subtracting. 5 and 6, you're multiplying by a scalar. If you flip it over, you're given 4 different matrices there, and you have many different operations. 11 through 14 are all those multi-step ones. So make sure you get to 11 through 14 before you leave. That way you can have time to ask questions if you need to, because those are going to be the trickiest. Okay? You guys have the rest of the time to work.